I'm Mackenzie. I'm the Senior Program Project Manager here at Women Who Code. And today we have a really interesting lightning talk called How Can Software Developers Help Mitigate Climate Change? So please welcome our amazing speaker, Beste Bayhan. Beste is a front-end engineer at Apiumhub with over 3 years of experience. She works with technologies such as React.js, TypeScript, Cypress, React Query, and Tailwind CSS. She likes to try new frameworks and investigate the front-end world to write articles for the company blog. Right now, she's really into the topic of green software. Thank you, Beste, for being here today. I'll now pass the session over to you.
Thank you very much, and thank you for giving me this opportunity. And thank you again to come to my presentation. I am really excited to be here and share some ideas about how we software developers can help mitigate climate change. First of all, I would like to introduce myself. My name is Beste. I am from Istanbul, Turkey, and I am a front-end engineer at Apiumhub, a software development hub based in Barcelona. And my interest on this topic started with Carbon Act 22, the first hackathon organized by the Green Software Foundation. Green Software Foundation is a software foundation, a non-profit organization which has big members such as Microsoft, GitHub, ThoughtWorks, Accenture, and Linux Foundation, and they aim to help IT sector to reduce its carbon emissions. And in my project, me and my two colleagues, we did an API. We developed an API to reduce carbon emissions of the IT processes. And we showed that by shifting the time of 1 million of IT processes, we could save 300,000 of carbon dioxide per year. And with this project, we won the most insightful prize, and this helped me to motivate on more investigating on this topic. And today, I would like to talk about these topics. I will explain all one by one. In my first graph, I would like to show you the temperature anomalies in the last 11,000 years. And as we can see, in the last 50 years, the rate of change is significant comparing to 11,000 years. In the past, 1 degree change could take hundreds and thousands of years, but since 1970s, we actually has risen approximately 1 degree. And according to a report of the Intergovernmental Panel on Climate Change on 2022, we have already reached the critical points in terms of irreversible climate change. And in these two graphs, I would like to show you the impact of ICT sector on climate change. And we can see that it changes from 1 to 6%, the greenhouse gas emissions. And it is way bigger than the aviation and the industry, which stands at 2%. And actually, we always criticize aviation industry, but also the information and communications technology sector is also emitting a lot of gas emissions. And regarding to the Sustainable Web Manifesto, if the internet were a country, it would be the 4th largest polluting country globally. And now I would like to talk about the green software term. Green software term is defined by the Green Software Foundation, the foundation I mentioned you before, and it combines climate science, hardware, software, electricity markets, and data center design to create carbon-efficient applications to emit the least amount of carbon possible. And now I will tell about the principles of sustainable software engineering. And I would like to note that these principles that I'm going to show you are independent of application domain, organization size or type, programming language or framework, and also cloud vendor or self-hosted. Our first principle is carbon. As we know, the temperature of Earth is linked to the amount of carbon in the atmosphere. And the IPCC's collective goal is to stabilize the temperature increase at 1.5 degree by 2100. And to do this, we need to achieve net zero emissions by 2050. And what does this net zero emission means? For every carbon that we emit in the atmosphere, we should extract the same amount to have the balance, carbon balance in our atmospheres. And to do this, it is essential to create carbon efficient applications. And also, if we can adapt carbon aware design principles, we can mitigate the climate change. And our second principle is the electricity. A large portion of electricity comes from the fossil fuels, and this leads to carbon emissions. And to decrease our electricity consumption, we can optimize our code, or we can try to reduce our unnecessary computational tasks. And with this, we can also decrease the amount of carbon pollution. And our third principle is the carbon intensity. The carbon intensity of electricity measures the amount of carbon emissions produced per unit of electricity consumed. And this is also referred as grams of carbon dioxide equivalent per kilowatt hour. And we have two carbon intensities depending on our energy resources. And if we have renewable energy sources like solar, wind, and hydroelectric, we would have the low carbon intensity one. But if we have, in contrast, like fossil fuels like coal, we would have high carbon intensity. And it also changes depending on the times and zones, since we don't have the same weather conditions for every time and zone. And there is one concept called carbon aware computing, and it is a concept that by adapting our electricity consumption to align with periods and locations of cleaner energy generation, we can contribute also to mitigate climate change. And our fourth principle is the embodied carbon. And embodied carbon is the amount of carbon pollution that emitted during the creation and disposal of a device. And if we can try to extend the expiry date of our hardwares, also we can, it will help us to, with our goal to be carbon efficient. And our fifth one is the energy proportionality. Energy proportionality is a measure of the relationship between power consumed in a computer system and the rate at which useful work is done. And as we can see, an idle computer is drawing 100 watt use, since one fully utilized computer is still drawing 200 watt use. And because of this relationship, the more we utilize a computer, the more efficient it becomes converting the electricity. And the other one is the network efficiency. A network is a series of routers and servers and switches, and every element on the network has have embodied carbon, and it also consumes electricity. And also for when we send the data, the amount of carbon we emit, it depends on many factors. The distance of the data travels, the size of the data, the number of hops between the network devices, and also the carbon intensities for the network devices for each zone, and the network protocol used, and also the mobile networks. And the other principle is the demand shaping. Demand shaping is different than the demand shifting. Instead of changing our zone or region, we try to shape our demand. It means that when we have a supply of renewable energy high, we do more in our applications. And if we have the supply of our renewable energy sources lower, we should do less in our applications. And this can be, we can give an example for this as the video conferencing softwares. When we have renewable energy sources supply lower, we can try to prioritize our audios instead of high quality videos. And the last principle is the optimization. One of the advice for this principle is to look end to end and step by step. And also simple solutions can significantly improve our carbon efficiency. And if we can architect an application that performs better in the same level of utilization, also it will reduce overall carbon. And now I would like to talk about what can we do to mitigate climate change. I split into 3 parts, and the first one is the green mode design. And regarding to Ismael Velasco's articles, the green mode design is the combination of 2 UX principles. And I highly recommend also the Ismael Velasco's blog. He has a lot of articles and investigation about on this topic. And he defines green mode design as giving users a reversible option for degraded but still functional performance in exchange for reduced emissions. And how we can do this? We can have images optional in our pages and also grayscale images, and we can try to compress our images without losing the quality. As we know, the images are the largest contributors to page weight. And we can also have the good user experience if our users knows how to interact and how to navigate in our applications, in our softwares. It also lower the screen time and also reduce the data transfer. And this will also help to reduce our carbon emissions. And we can also have sound-only videos or transcript-only audios, which we know that video is the most data-intensive form of content. And with this, if we select properly our videos to use, it will also reduce the carbon emissions. And also choosing fonts are important. If we can choose the system fonts like Times New Roman and Arial, but if we don't like them and we would like to choose another package, maybe we can try to be efficient in the number of font packages. And also, if we can have dark mode in our applications, dark mode is the first techniques to use to save energy, and it will also help to reduce our carbon emissions. And I wrote also using less JavaScript. I would like to say that if we could try to find web technologies like CSS to create our animations and front-end interactions in our pages, and it would reduce the JavaScript file size, and it will also help us to have less carbon emission. And in the second part, I would like to show the green cloud part. And if we can choose a closed data center to our users, or if we can try to use green cloud providers or zones. Now, like all the big companies such as Microsoft Azure, Google Cloud, and Amazon, they are also offering tooling and dashboards for understanding the impact of our services that consume through their platforms. And also we can use a content delivery network. It is also a great solution when we have users, when we have worldwide users and they would like to download any big files or images, we can have them to download from a local CDN. And if we can also reduce our page loads and data consumption and reduce our HTTP requests and data exchanges, it would also reduce our carbon footprint. And the last one is the green architecture. It is really important to write clean code, to not duplicate our codes and try to recycle our code, and also try to avoid our loops. It would be also good for the environment. And if we can try to build static web pages, and if we can use progressive web app technology, which consumes less energy, it would also reduce our carbon emissions. Thank you very much for listening to me. I hope it will remind all of us again the urgency of the situation, and we know that we can try to do sustainable decisions and create innovative solutions to this. Thank you.
Thank you so much, Beste, for that amazing presentation. Okay, so we do have a question from Paige. What resources do you recommend to build on these principles?
Yeah, I have a lot of resources, but like I can send it from the if you can send me an email, like the person I think called Paige, no, I can send a lot of resources. Actually, I've put in my presentations like a part where the green cloud. I will check if I can go back. Yeah, this one, for example, Cloud Carbon Footprint, it's a free and open source platform where you can check your system to like how impact on the cloud. And there is also like some tools on the Chrome, like when you are playing a YouTube video or any other video, like when you change when you change your tab, it is not showing the video, instead only like audio. And there are like many tools to use. Actually, I am also like when I investigate more, I learn a lot of more things, but like the people are starting to create more and more, and hope it will happen. And also, maybe I can tell there is a Slack community called Climate Action Tag. Maybe I can write this here, Climate Action Tag. And there are a lot of also a lot of examples and tools that people are uh, showing, setting all the days.
Amazing. Thank you so much again for your presentation today.
Have a good day. Bye.
Bye. Thank you.
Thank you.